Hello everyone, my name is Nikhil and I'm part of the cloud team based in APAC. This demo is targeted for someone who is interested in learning how the Kubernetes, which is a container orchestration tool, connects to MongoDB Atlas. The reason behind recording this session is the increase in the number of requests from our customers over SFSC who are using Kubernetes to deploy their application and wants to connect to MongoDB Atlas securely. To be able to help the customers and troubleshoot the problems, it is important for us to know how actually Kubernetes works and how can we connect to MongoDB Atlas by ourselves. So in this demo, what we'll be discussing is as below. So we'll be discussing about the AWS Elastic Kubernetes Service, how to deploy an EKS cluster plane and its components, VPC for EKS, EKS worker nodes, and then we'll be deploying a Node.js application. And then we'll see how we can connect MongoDB Atlas to our Node.js application over the public network and VPC peering. So before I move forward, I would like to tell you how actually a managed Kubernetes service, which is EKS, looks like and how it works behind the scenes. So as you can see here, there's a kubectl uh, icon or a command which is shown to you. So kubectl is actually a CLI tool which helps us in issuing commands to the Kubernetes infrastructure. So this is a machine which will be needed for issuing commands, whether to deploy an application, to manage an application, to delete something, or to create something new. So we'll be using this command, and you'll see how I use these commands approximately every time I am doing something. I'm using kubectl. Now, before discussing anything, it's important for us to know how actually AWS provides us the EKS service. So what AWS does, it gives us an EKS control plane, which means that I mean, as you see, this is the above one. Uh, it's a cluster which is totally managed by AWS. So we just have to pass few details, and AWS will create a managed Kubernetes control plane for us, which will include the master node. So I won't go much in detail what master and worker nodes are, but to give you a short uh, information. So master node is something which takes inputs from us using the kubectl command and passes it onto the worker nodes. And the worker nodes are the actual nodes. These are actually the EC2 machines on which our application is deployed. So that's the flow. I mean, the master nodes would take the input from us and pass it on those inputs to the worker nodes so that the worker nodes can then process whatever request has been issued and take actions accordingly and give us the output of the commands. So the customer, any customer who would then be accessing our application, um, or we can say the end customer, end user. So they would be clients who will be connecting to directly to our worker nodes. They would not be connecting to the master nodes or anywhere else. So we'll have a load balancer in place. This can be a classic load balancer or a network load balancer as AWS provides, and we can use based upon our needs. And then these are the group of EC2 worker nodes which are inside an auto scaling group. So they can auto scale vertically or horizontally as we want. So there are plugins which can be used for horizontally scaling them or vertically scaling them. And these are inside a custom VPC that we'll be deploying with all the network configurations which are required to provision an EKS worker nodes on Amazon EC2. So this is a brief detail on how actually the EKS functions, and these are the work and these EC2 worker nodes are the actual nodes which will be connecting to our MongoDB Atlas. So we'll see how this works. So let's start with completing our prerequisites. So our prerequisites would be installing kubectl, creating a custom VPC, then we'll have an EC2 instance on which we'll be uh, installing all our tools, which would be kubectl, AWS IAM Authenticator. I'll get to what these tools are in detail once we start working with them. So first, let's configure our VPC. So we'll be configuring this VPC by going through the documentation from AWS. So and doing it. So yeah, let's go with it. So we'll have both public and private subnets. So it totally depends upon how a customer wants to configure their Kubernetes cluster. So we'll have both public and private subnets. For more details, you can go through these documentations on AWS's website, and you'll get to know more how they are configuring it. So it's basically two public subnet blocks and two private subnet blocks created for us. So we'll be using this CloudFormation template for configuring our VPC. Let's go to CloudFormation, create stack. We'll use a template which is provided. Click on next, give it a name. So we'll give this the name as EKS VPC. So this is the VPC block. If you want, you can change this. So yes, I'll be changing this block. I'll be using 172.31.0.0/16. And similarly, I'll be changing these two 172.31.0.0/18, let's say, or let's keep it very simple. Give it 1.0/24, copy it, paste it, keep on changing, and click next. Okay, underscore is not allowed. We'll move it. Click on next. So we can give tags. I'll provide one tag to it as a name, which will say EKS VPC. No more tags. Nothing at all required from this. Nothing more actually. So this will show us that it is going to create all these things for us, 5 things. All right, and create stack. So we got to wait until it creates the stack for us. So I'll be back once this VPC is ready for us to proceed. While our VPC was getting created, let us go ahead and create an IAM user, a few roles, so that we can move ahead with our cluster creation. Since this is one of the main points to remember, that EKS cluster creation, its management, and any changes being made to it, whether you want to connect to it, you want to manage it, all needs to be done through an IAM user. You cannot use your root access credentials to create a cluster and then manage it. Amazon does not allows that to do. So we'll go ahead, create a user, and we'll have both access created for this user. One is the credentials, which is accessing the UI, and another one would be the programmatic access. So console and programmatic access both will create these two credentials for a user. So let's go ahead and create the user first. So let's say I want to create the user with my name, Nikhil. I'll have a programmatic access and an AWS management console access. I'll use the custom password so that I don't have to change it again. And I'll disable this password reset. I'll attach existing policy of administrator access so that I have full access to this AWS account being an IAM user. Tags are optional. Let's leave that and let's create the user. So once the user is created, you can see I have the access key ID and the secret access key. This is very similar to the API keys that we get in MongoDB Atlas. So that key gives us the access to use Atlas through APIs. Similarly, these two keys gives us the access to use AWS using APIs. So I'll just save these for future use. So these are some old keys. I'll remove them. I'll copy the new one here. I'll anyhow be terminating this user after this session. So doesn't matter I'm showing these keys in this video, but you should always keep them as a secret. No one should be able to get hold of your secret access key or access key ID. I'll copy this URL because I'll now be using this to log in as an IAM user. I'll close this. I'll sign out and I'll now use this link. Right, so there you go, Nikhil. So this is an IAM user login. I'm pretty much sure every one of us is aware because we use this whenever we want to log into our MongoDB's AWS dashboard. Now, let's head to IAM again because we created this user and we need to create an IAM role so that our EKS services can further manage other services if they need to. So we'll create a role, go to IAM role and look out for EKS and select EKS cluster. So this allows access to other AWS service resources that are required to operate clusters managed by EKS. So anything, I mean, like scaling, horizontal or vertical, um, installing something on your worker nodes or deleting your worker nodes or adding more worker nodes. So EKS can now manage everything. So there's a predefined policy, EKS cluster policy, which will be added here. Tags are optional. We'll leave it. And we'll give this role a name, AWS EKS access to services and create role. So you can see here we have the service available. Um, Now what we'll do, we'll head back to our EC2 management console. I'll have to reload these pages. They were logged in using the root user. So you can see there's a management server already running. So I'll be using this server to further access or manage my Kubernetes infrastructure. So we'll get back to those things later on. Now let's head to Amazon EKS dashboard, reload this. Get back to Amazon EKS. Give it a name. We'll give it EKS Atlas. Next, AWS EKS access to services. The role that I just created. So this role will help Kubernetes cluster to manage resources on my behalf. No other changes on this page. We'll select the VPC that we created, EKS VPC. The subnets are automatically chosen. Security group. So I'll choose EKS VPC control plane security group because this is the one created for this particular EKS cluster. Now, the endpoint access. So if I choose public, um, even my all the worker node traffic and my clusters endpoint, everything would be available outside my VPC, which means they can be accessed over the public internet, which I would not want. For private, Everything becomes accessible only inside the VPC, which is again, I would not want to do that because I might need to access my endpoint from outside this VPC. Public and private, yeah, this is the combination that I would generally keep so that anytime I want to access my endpoint outside this VPC, I can do that. Let's say I want to go down the timeline and manage my Kubernetes cluster from my own machine. So yes, that I could do. Click next, next, and this is a review page. You can always review what all you did in the last three steps and click on create. So the EKS cluster creation does takes some amount of time. So it would take somewhere around 10 to 15 minutes for the cluster to be created because a lot goes behind creating an EKS cluster. It would launch an EC2 instance, manage your master node. It would configure it the entire Kubernetes setup on it and everything, and then it would give us the cluster for our use. So once the cluster is ready, we can move ahead with the deployment of our. So our cluster is now ready. As you can see, we have all the available details here. It's server endpoint, its creation time, certificate authorities, ARNs, everything is now available, which means that we are now good to move with creating our worker nodes. So to create the worker nodes, we'll once again look into the AWS documentation, and what we'll do is we'll copy this CloudFormation template. We'll go to our CloudFormation page. So from services, we'll choose CloudFormation. And you can see we already have an EKS VPC, so which we created earlier. Click on create stack, give the URL, next, give it a name. So I'll give it EKS worker nodes. It asks for the EKS cluster name so that it can connect to it. EKS-Atlas, the security group, so that it can add some rules to it. So we'll choose the same we chose for the cluster. So this one it is. Group name, I'll go for EKS worker. Now comes the auto scaling part. Like if the load on my application increases, how it should scale, how many number of nodes should be added. So for now, since this is demo, I'll keep everything to 1 and max size we can leave because we're not going to head towards that. Rest, keep it as default. Key name, well, that's not required, but anytime if there's a use case where you have to log into one of your worker nodes, you can always use this key. It's always better to have a key associated with it. VPC ID, choose the new VPC that you created. And subnets, attach all 4 subnets so that you always have high availability available for your application. No more changes required. Click on next. You can always review all the changes you have made and click create stack. So this will now create a EKS worker node cluster for us. Now while this is being created, let's go back to our EC2, and I showed you that we'll be using this particular server, but I thought, okay, let's go ahead and build everything from scratch, which will give a good idea how to launch an EC2 instance, as well as what all firewall rules and settings should be there. So click on launch instance, use Ubuntu 16. You can go ahead with T2 Micro, which is a free tier eligible instance. Choose the new VPC, keep it inside the same VPC, and choose a public subnet because you will have to log into this instance. And if this is inside a private subnet, this won't get a public IP address and make it impossible for you to log in. So make sure that you choose the correct subnet, else you'll have to terminate your instance and launch it again because there's no way you can change the subnet of your instance. Click next add storage, and this I'll go with the default. I don't need much storage on my machine. I'll add the tag name EKS management server, or let's go with machine. That looks good. Security group. Now, we only need one firewall rule for this particular instance, and that is SSH. So we'll create a new security group and attach the SSH firewall rules. This is my EKS management machine security group. Make sure to always give a meaningful name to anything you create, because that makes it easier for anyone, or I mean yourself, to identify things among a lot of things which are already in place. Source. So always make sure that you have a dedicated IP address for SSH. Do not leave it open to public. And you can always go ahead and change it if your IP is not static. This is the review page. Click on launch. It automatically selected one of my SSH keys. If you don't have one, you can create one. Just choose the create new key pair and it would ask you for the name, give it, and once you click this launch, it would download that key for you. But since I already have this key, I won't do that. I would just acknowledge that I have this private key available with me, and I would click on launch instances. Now, so this is my management machine, and you see my worker node is also getting created. So let's head back to our CloudFormation stack and see what's the progress. So it's still in progress, so we'll wait for this to complete. And while this is completing, we'll head to our management machine. Yeah, so my machine is ready to log in. It has a public IP address. So I'll copy this public IP address. I'll shift to my terminal. I'll log in into this machine. Yes, this is the first time I'm logging into this machine, so it's asking for my confirmation. And I would use sudo su to elevate my privileges as a root user. I'll now run this command apt-get update. This will update all my repositories, the default repositories for Ubuntu with the latest packages. And clear the screen. Okay, so now we are ready to install the CLI tools. So there will be three CLI tools that we'll be installing. First is AWS IAM Authenticator. Second would be kubectl, and third would be AWS CLI. So to install all those three tools, the best place to look out is again the AWS documentation. So installing the AWS IAM Authenticator. So these are all the steps listed for a Linux machine. Copy the first command, paste it, hit enter. So it has been downloaded, as you can see. This is the file. We'll make this file executable as shown here. This is, this is very simple. You can either copy or type it on your own as you are comfortable. Now, since this is a custom binary or a downloaded binary which my system is not aware of, so anytime I have to use it, I'll have to come to this location and then run the command which I would not want. I would want to execute this particular binary from anywhere in the on this machine, any directory I'm into. So what I'll do, I'll create a path, or I'll create a directory wherein I can put this particular binary, and then I'll pass that path to my shell profile. So there are two ways. One, you can keep this inside your slash usr slash local slash bin or slash bin, or any directory which your machine's default path is, or you can create your own path and pass it to your shell profile. So I'll be creating my own path and putting it inside that, putting this particular binary into that and passing it to my shell profile. So copy this, paste it. So what it's doing, it's creating a bin for directory. You can call it folder or directory inside the home directory. It will copy this particular binary to this bin directory and will export this path to my shell profile. Hit enter, and you can now add $home/bin to your path environment variable. So this is important. Now, if you run this command, you should get an output from anywhere. So I can still get an output inside this directory. Let's move to some other directory and see. Yes, I can. So what I wanted to achieve is using this command from anywhere inside this machine, and I can now do that. I'll clear the screen, and next is kubectl. So we used Kubernetes 1.17 for our EKS cluster. If you want to verify, you can go to the EKS dashboard and see, yes, our Kubernetes version is 1.17. Just copy this kubectl binary locate download command. This is downloaded. Now what we'll do, we'll follow the same process as we did um, for the AWS IAM Authenticator. We'll copy this particular binary to that same directory so that it is also accessible from anywhere inside the machine. CP, okay, before that, let's make it executable. Chmod plus X kubectl. So our file is now executable and we'll move it to that same location. So we'll use CP kubectl to $home/bin/kubectl, and there you go. So I can now move to another directory and check if the kubectl command is available or not. It is. So we successfully installed two tools, AWS IAM Authenticator and kubectl. So now we'll install AWS CLI. Well, most of us think that installing AWS CLI is pretty easy. It's already available on the Amazon's instances. But I would like to inform that the default repositories contain an older version of AWS CLI and it does not has EKS available inside it. So look out for the AWS documentation to download the latest version of AWS CLI, else the EKS command won't be available and you won't be able to proceed further. So we'll move to the AWS documentation again and we'll look out for install AWS CLI, and there you go. So there are two CLI versions. We'll go ahead with the CLI version 1 and we'll install using pip on Linux because that's the most easiest way to do it. Copy the command, download get pip file, and use your Python 3 command to install pip. So it says that these are installed in /root/.local/bin, which is not on path. So you should make sure that this path gets added to your shell profile, else pip3 won't be accessible. So we'll do just that. We'll copy this command, export command, to export this path to the shell, and we'll source not the entire, We'll make a change. You can look out for the exact profile file to reload your bash profile by ls-a and this. So it will show you what's the profile name. So in my case, it is dot profile. It might be something else in your case. So make sure to check this if this command gives you an error, because there are different type of shells and the name differs for each of them. Now if I run pip 3 hyphen hyphen version, yes, so it gives me the version details. So which means I'm good to run my next command to install the AWS CLI. So what this command does, it installs AWS CLI, or if it is already installed, it will upgrade it and it will install it as the root user or the user with which you are signed in. Great. So AWS CLI is now installed and this shows us. Now head back to our AWS dashboard and see if AWS Worker Nodes has completed creation. Yes, it has. We'll go to the output section. We'll need few details from here because we'll need to authenticate our worker nodes. So what we'll do, we'll go back to the worker nodes documentation. We'll scroll down a bit. Yeah, so this is the step. It says to enable nodes to join your cluster, we need to apply an IAM authenticator configuration map. So we'll download this configuration map using this URL. So it is here. We'll edit it and we'll pass the role ARN. It asks for the ARN of the instance role for my worker nodes. So I'll show you from where to get that. So in your CloudFormation stack, you go to outputs for the worker nodes and look out for node instance role. And the value for this is what you need here. So copy it and paste it. Okay, so we made changes to our AWS auth configuration map YAML file, but before moving ahead with making any uh, changes using this file, we'll first have to authenticate this machine to AWS, which is why we initially created our access keys, if you remember. So we'll use those and add the AWS configuration so that it can authenticate when we run any command. So it's asking for the access ID. Just copy it, paste it, copy, paste. The region is US East 1. Great. So there are multiple ways how you can authenticate your AWS account when you run an AWS command. So this is one of those, but what I would suggest is never keeping your credentials on a public machine. You can use the export command as well, like export access key ID, export secret access key, and then using it from a shell. But yeah, that is a tedious process because that would be needed every time you log in into your shell. You'll have to do that if you want to run AWS command. So this is an easy one, which is why I'm using it for this demo purpose. I'll clear my screen. Now, my kubectl command still is unaware of the EKS cluster which we created. Because if we see the config, it gives us a blank set of key value pairs, which means it has nothing. It knows nothing about my EKS cluster. So what I will be doing, I'll be adding my EKS cluster details to this config using an AWS command. So use this command, which is AWS, which means I am now going to use the AWS CLI, EK, and the service is EKS. in the US East 1 region to update the kube config, which is this hyphen hyphen name. I'll give the name of my cluster. It's EKS hyphen Atlas and hit enter. Now it gives us an output that it added new context. So if I run kubectl config view again, now this time it's not an empty set. This is a lot of details right for us here. So now before doing anything, let's authenticate our AWS as well, AWS IAM authenticator as well. Let's make changes to it. So kubectl apply hyphen f AWS hyphen auth cm.yaml. So what kubectl apply does, it helps you to install, update anything or any services, any deployment into your Kubernetes cluster. So if you run this command for a YAML file for the first time, this will install it or deploy it initially. If you make some changes to this file and run this command again, it will update it. So since we're running it for the first time, this will make sure that things are installed or deployed for the first time. Meanwhile, this is being done. Let's get back to our EC2 page, go to security groups, and make sure you add an inbound rule to it, which makes this system, my management instance, able to access this particular Kubernetes cluster over port 443, because currently it's allowed only for this particular security group, but I would like to access it from my own machine as well. So I'll add this security group. I'll save the rules. I'll go here and you can see due to this 440 it timed out. 443 port not being allowed apart from its own security group. I'll hit enter and this is done. So it created a config map for this cluster. Now, if I go ahead and run kubectl get nodes, it says it's not ready yet. It is currently in the process of adding it as a worker node. So it will take some time. So what we can do is we can run hyphen hyphen add hyphen hyphen watch to this command to see what happens. So it is ready. Luckily, we don't have to wait much. And the worker nodes have the version 1.14.9. All right, so we have EKS cluster now ready, and we'll now connect our Node.js application to MongoDB Atlas. And currently, I have a worker node without public IP address, which means that it's the best scenario to connect to MongoDB Atlas over VPC peering and take advantage of the private network communication. So what we'll do first is we'll set up VPC peering among AWS and MongoDB Atlas. So head to the let's head to the VPC section of AWS. Let's go to VPCs. Yes, and that is my VPC. So I'll initiate VPC peering, add peering connection, AWS, account ID. So this is my account ID, my VPC ID, then the VPC CIDR would be this. Choose a region, US East 1, and it's selected. So I'll initiate peering from here. So now the peering has been initiated. So Let's go to the AWS peering connection section, and I have the request. So I'll accept it, accepted, and I'll now create the route table entries. So let me sort this. I'll add it to both of my private subnets, routes, edit routes, add 192.168 dot mm, 248.0/21. I choose peering connection. This is it. Save routes, close. Then for AZ2, edit it. Same here as well, 192.168.248.0/21. Peering connection, save, close. So now we have to wait until the VPC pairing is available for us to use. Just still waiting for approval. Yes, it does take some amount of time, very on few occasions. So meanwhile this is happening, let's go to our EC2 console, or rather to the cloud formation console, and add one more node, and hope that this gets created in the public subnet so that we can test our public connectivity as well. So what I'll do, I'll just update this template, set the minimum size to 2, this to 2 as well. Next, next, and acknowledge the changes and update the stack. So the update has started, and this should start the launch of a new EC2 instance shortly. Yes, we got to wait for some time that it's available for us to use. Yeah, so you see this has started. Unlucky for us, this too has picked up a private subnet. That's not a problem. Once this is done, we can again increase one more. So it would never deploy instances in the same availability zone until there are multiple. Uh, so once this plan is finished, yeah, so it has completed. So we can update it again. Next, 3, 3, and next, next. I acknowledge and update stack. So this would take some time. Meanwhile, let's see if this has completed or not. Oh, so it's still waiting. So let's wait for some time unless this gets completed, and then we'll move ahead with deploying the app and see how it works. Okay, so we're all ready with deploying our Node.js application now. So we have our cluster ready, our MongoDB Atlas cluster ready, EKS cluster ready. Everything is now ready for us to move ahead. Our VPC peering is also active now. But first, what we'll be doing is we'll be connecting to our MongoDB Atlas cluster using the public IP address. So for that, what I have done is I have made a small change in my YAML file. I have made sure that this particular pod gets deployed to the node which has public network. So you see here it's mentioned public, and I have labeled my node as network equals to public. So this will make sure that my pod gets deployed onto the public worker node. Now, my public worker node is this, which is 184.72.210.22. I'll copy this IP address and I'll show it here in network access. See, this is already whitelisted. Now, what we'll do is first I'll clear everything inside my cluster so that we know that there's always a new data coming in. Drop. All right, so this is now empty. So let's move to the terminal and deploy this application. kubectl apply -f knode.yaml. This is now deployed. kubectl get pods. This shows as running. Let's see the logs. We'll have to wait a bit. So that is the application warning and all. Yeah, we got to see them. So yeah, it failed to connect. So now what I'll do is I'll troubleshoot what happened and why it failed. My IP has been whitelisted. So what's there is actually which is hampering this connection. So I'll go to my VPC section of AWS and I'll see if I have an internet gateway. Yeah, I do have, which is attached. My route table, all my public subnets routes has internet gateway, which means that in and out is always allowed. Public connection can be set up. Next, I'll see my network ACLs for this particular VPC. So I check the inbound rules. It's first allowed, then deny. For the outbound rules as well, it's first allowed, then deny. Now, the best way to troubleshoot is to log into your worker node since it has public IP address, so it's quite easy to log in. And I have logged in onto my worker node now. As you can see, this is the 172.168.180 node, which is my worker node. And if you want to see the node on which my app is currently deployed, so I'll just show that to you. It's kubectl get pods hyphen hyphen output equals to wide, right? And it will show you that this is deployed on this particular node, that is 172.31.180. Now I'll ping my uh, primary of the Atlas cluster. I'll find out, okay, this one is the primary. I'll ping it. So what's happening here is, as you see, I'm using the public connectivity string here. This is the public host name. We know that the private host name consists of PRI in between, which distinguishes and helps us to find out which one is the public and which one is the private connection string. And we can see that this is getting resolved to 192.168.253.6, which is the private IP address for this particular node. With AWS, that's one of the main problem which we face, that my DNS knows that there is a way to get to this particular host using a private IP address, because yes, we have done VPC peering. So the VPC has an idea how to route through private IP, and this is what it is doing. It is trying to route using the private IP address, but I have not added this route table entry to my public subnet. So as you can see, if I go to subnets, sorry, the route tables, and look out for the routes, I do not have this peering connection route in my public subnet as I have it in my private. So which is why it is not able to connect to my Atlas cluster, and I'm getting that timeout error when I'm checking the logs for my pod. Now, how do we troubleshoot this? To troubleshoot this, uh, in AWS, what you can do is you can create a new DHCP option set. So this will make sure that the DHCP with or the domain name, the DNS which is gonna be used is not going to be the AWS DNS. We'll be using a public DNS which is 8.8.8.8. So for that, I already have a DHCP option set created. Uh, and if you see the details, I have set in the domain name servers at 8.8.8.8. Now, if I go to VPC, I can change this DSCP option set. I'll map it to my new one. I'll save it. I'll come back to my notes to make sure that this takes effect. I'll reboot my worker pod from inside. Never reboot your worker pod from the AWS console, because that would lead to the termination of this particular instance and the new instance will be launched, which will delay your troubleshooting and connectivity. So the best way to get your settings or configurations into effect is always try to reboot after logging into your machine if you can. So I have issued this command reboot. Now it would take few seconds for me to log in back to this machine again. Yeah, so I'm back to this machine. I'm logged in. And if now I issue this ping command, you can see that I am now able to ping this host name, which is my cluster's host name, primary host name, and it is resolving to a public IP address because the external DNS, which is 8.8.8.8, is not aware of any kind of private IP communication, gateway, route table, nothing. It has no idea what's happening. So this is allowing me to connect using the public network. That's good that I can now ping it, which means that most of my problems should be solved now. So I'll again deploy this kubectl delete deployments knote. I'll delete my deployment and I'll deploy it again. And this should connect immediately to me. Yeah, this has connected. This has pushed in results, but it shut downs after uh, inserting the data, so it shows me crash loop back off. So this is particularly in my case as my application is designed to work. But if your application is designed to work continuously and never exit, you'll always get the status as ready 1 cross 1 and the status as running. So I'll check the logs. It should give me that all the data has been inserted. Yes. So I was very easily able to insert data once my application was able to talk to MongoDB cluster over the public IP address. Sorry. To confirm this, let's head back to our MongoDB Atlas cluster. Click on collections. It does take some amount of time sometimes, yes, but I do have the data now. If you remember, I cleared everything from here and we have 3 entries as of now, which means that my Node.js application was able to connect to MongoDB Atlas cluster over the public IP address. What I'll do now is I'll delete this deployment. Right, this is now deleted. I'll log out from here. I don't need this machine anymore. I don't need to be logged in. I'll delete this database again. Now this is an empty set again. Now what we'll do is we'll connect to our MongoDB Atlas cluster over the private IP address. So I'll show you what that YAML file looks like. So as you can see, I have not mentioned the network should be public. There is no node selector. This would automatically go to any of the machines. And since all the machines have a private IP address, so any machine uh, with a private IP address and has a route table entry in its subnet should be able to route my data from my application to the MongoDB Atlas cluster. Also, to make sure that uh, accidentally I do not land up on that public node, what I'll be doing is I'll be reverting my DHCP option sets to the default one. Save, close, go back to that public node, log in once, elevate your privileges, and run reboot now. Remember, never reboot from AWS console if you have to make these changes to your settings or configurations. This saves a lot of time. So now this has been rebooted. Now what I'll do, I'll run the command of kubectl apply -f knote pre dot yaml. Hit enter. This is created. Kubectl get pods. You see this has status as completed, restarts one already, which means that there should be data in the logs. It should not have failed. So kubectl logs -f. Yes, this has data, and this was able to connect to my Atlas cluster over the private IP address, because there was no way it was going to connect using the public IP, because I reverted my DHCP option sets, and when the default AWS DNS is being used, it will always use the private IP address. And since this also has a private connection string inside it, so this will automatically connect you to the Atlas cluster over private network. Now, what we can do here more is, let's say, let's check first where was this deployed. So kubectl get pods hyphen output equals to void. Make sure that this was not deployed over the public IP machine and we have no um, confusion. So yes, this was not deployed over the public worker node. This was deployed over the private worker node. We can confirm that from our EC2 console. So you see this 3167, it is the private IP address for this particular worker node, which does not has a public IP address and is inside the private subnet. So yes, so now we are able to connect to our MongoDB Atlas cluster from AWS EKS over both public and private network. So we have to remember two things here, basically, that if you want to connect to MongoDB Atlas using Kubernetes, you have both these options available. You can either use worker node which is inside a public IP and deploy your pods over it and connect to the Atlas cluster using the public IP addresses, or set up VPC peering and connect using private IP address. So but if you once you have deployed or connected your Kubernetes application using VPC peering, it won't be possible for you to connect to the MongoDB Atlas cluster from the public worker node, because then all the IP addresses would start resolving to the public IP address. And if your public subnet does not has entries to the peering connections, it won't be able to connect you to the MongoDB Atlas. So that's one workaround. Change the DHCP option set, restart your public worker node, and you should be able to connect. So that is all on how connecting your Kubernetes cluster, which is a managed Kubernetes service, AWS EKS, to MongoDB Atlas using public internet and private network. So thanks for watching this entire demo session through and giving your precious time to this recording. If you've got any questions, feel free to ping me over Slack or email me, and I'll be more than happy to help you in resolving any queries related to Kubernetes and Atlas cluster. Thank you.